Test case design technique. As the name itself is indicating, it is a technique for designing test cases. These techniques have been used main thing about this testing technique is that it helps to identify those test cases which are very difficult to identify if we do not use these design techniques, test design techniques. There are 5 software testing techniques which we should understand. They are not very hard to understand and they are very useful for designing test cases. We will see one by one all these test case design techniques. So they are given as below: boundary value analysis, equivalence class part testing, decision table based testing, state transition, and error caching. First is boundary value analysis. It is very useful software testing technique which helps us in designing test cases. We should very carefully understand where it is used and when it is used. For example, we have test case scenario that all citizens of the country who are above 18 years and below 45 years of age are eligible to take COVID vaccine. However, we can clearly see that we have two boundary values, 18 and 45. Now, main thing to understand here is that what are the values that should be considered in test cases, so that all combination of all the values that is required for testing particular test scenario is covered. We generally consider all the values that is just above and below the boundary value. We can take same test case with value 17 and 19 because 18 is boundary value. Same applies to value 45 and 46 because same applies to value 45, and we can use 44 and 46, which is one value above and below the boundary value. So remember that for every boundary value there are two additional values that needs to be tested, which means that if there are two boundary values, then there will be 6 test cases in total with 6 different values containing one value above and one value below the. Suppose that there is any input condition and it is valued between 18 to 45. So boundary values are 17, 18 and 19 and 44, 45 and 46. Now, next comes equivalence class partitioning. It may be considered similar to boundary value analysis. and different as well from boundary value analysis. Suppose there are range of values from which we are required to make test cases. Then this technique comes into picture. Let us understand it with the help of an example. For example, we have test case scenario. That all the citizens of the country who are between 18 and 45 years and 60 years to 80 years of age are eligible to take COVID vaccine. Now you can clearly see that we do not have particular boundary value. But we have range of boundary values, which means that all our input conditions are valid between these range of boundary values. Here we have two valid range of value. One is between 18 and 45 years and other one is between 60 to 80 years. Now point to consider here is that we have invalid range of values as well. First one is between 0 to 18 years. Second one is between 45 to 60 years. And third one is above 80 years. So when we are making test cases, we can make two test cases with valid range of values and we can make three test cases with invalid range of values. Most important point to be noted here is that we can't take any value we can take any value from valid range of values and invalid range of values in test cases. Unlike boundary value analysis where there is restriction to select one value above and one value down, one value below the boundary value, there is no such restriction in equivalence class partitioning, and we can choose any value from valid range of values as well as invalid range of values. Let us suppose that input conditions are valid between ranges which are given as below, 1 to 10 and 20 to 30. Now we will divide range into 5 equivalence class which are given as below. Eighteen to 45 and 60 to 80. Now we will divide the range into 5 equivalence class partitioning which are given as below and which will give us better picture to design test cases. We can design test cases from any value from the classes that are given as below. 1 to 18 invalid, 45 to 60 invalid, above 80 invalid, 18 to 45 valid, 60 to 80 valid. Now that we have got all valid and invalid classes, we can select values from each class. For example, you can consider values given as below, which comes from invalid and valid classes like 7, 20, 47, 70. We will see some more test case design techniques in next video. Thanks for watching.